about CI for big science as a team sport. So I changed my title of the slides a little bit more broader than it was advertised. And first, it is probably obvious to people in this room, but if it wasn't, big science is a team sport. Ranging from the billion to the 10 million and kind of facilities, instrumentation, experiments, they all have one thing in common, that they have entire communities behind them. It's not a single PI, it is multi-institutional, often multinational. And so then if you accept that as a fact of life, that it takes a village or a country or whatever to make these major facilities work, then the next obvious thing is that NSF major facilities benefit from an open cyber infrastructure that enables their communities to contribute in-kind resources. And so what I mean by this is that we all know what open science is, or at least have sort of a vague sense. We all know what open data is, vague sense. We all know what open source is. What's the least talked about, and in my mind, the obvious thing that we should be talking more about is open cyber infrastructure, open infrastructure in general. So what I mean by this is that there ought to be a way that the major facilities can assemble for themselves compute, data access, devices potentially in an open infrastructure where somebody else runs the plumbing, and you guys can, the major facilities can assemble out of that plumbing their resources, their infrastructure that they need, and allow for in-kind contributions. So once you accept that as a need, then there is sort of kind of three ways of doing this today. You can either, and they depend on they distinguish themselves by where in the software stack you're attaching yourself. You can either attach yourself very low in the software stack, and on my slide, that's very top at the top. So this is an inverted stack in a way. You can go all the way to the operating system and the Kubernetes layer, and that's sort of what the National Research Platform does. We actually offer you the ability to just be responsible for deploying hardware into a rack, hooking up power, hooking up networking, and then we take over all the way from the base OS up to everything else. And so that's one way of integrating. And then in the opposite, from the opposite direction, you can operate your own storage and compute clusters, and then we can federate those storage and compute clusters and therefore sort of integrate at the top of the stack. And that's what OSG and PATH do. They combine storage systems with each other into a federation. They combine compute clusters with each other into a federated computing. And institutions may choose the integration layer that they want, depending on their cybersecurity stance. There's lots of institutions who would be, where it is completely antithetical to rack a piece of hardware and then give me IPMI access and do everything else from a remote institution where they don't control and can fire me because I'm the sysadmin. That is for many places antithetical. For many places that is totally in line with what they're willing to do. And so in the end, the institutions that join the major facilities with their in-kind contributions get to pick where in the stack they want to connect, but connectivity in an open infrastructure is guaranteed either which way. And so now, after these more general comments, let me make some specific comments on the specific project that is new on the block. The project that's new on the block is the National Research Platform. This is a Category 2 system funded by the NSF. And I'm going to focus on just one aspect of it. It has many aspects. The one aspect I want to focus on is that we have a concept of regional Ceph storage systems. We then have a concept, and in that regional Ceph storage systems, we have a concept that researchers control the replication at the path in the file system level. So I'm Jane Doe. I own / blah, blah, / Jane Doe. And inside Jane Doe, there is Foo and Ba. And Ba should be going to Massachusetts and San Diego, and Foo should be going to Lincoln. And I control that as at the application level or as the account level, and I have my allocation that I have on the system. Therefore, I can split the umpteen terabytes that I've given into 1 terabyte goes here and 10 terabyte goes here and the remainder goes there. And therefore, I control where my data is, to what extent it gets replicated across regional storage and so forth. So that's one piece. The next piece is we operate a content delivery network in collaboration with Path/OSG that has caches in the network backbone in such a way that there's no place in the US that is further away from a cache than 500 miles. And you see that it's not quite working. There's the El Paso region, which is sort of just about above 500 miles away. Basically, all of these circles are 500-mile circles on the continental USA. And everywhere where the circles touch, you have locations of more than one cache within 500 miles. And everywhere where there's gray space, you don't reach it within 500 miles. And this is what we're deploying. In addition, all of this is open. Anybody can join it. And I want to just show you one example of how you join data and storage into this, and just give you a mental model. This is the mental model for integration of an institutional data origin. We distinguish an origin of data is where the data is actually located more or less permanently until it gets deleted. And a cache is where it is ephemeral, where things flow past depending on access. And so data origins, we're open for anybody to come with an origin. And the mental model is that you have your file system potentially behind your institutional firewall. You put a host onto that firewall that is dual homed. It talks to both sides. That host, therefore, that host joins some Kubernetes infrastructure, for example, ours, and we control this host via IPMI, for example. And then we're responsible for putting services on there such that your data, whatever data you export to that host, which is inside your institution and reachable via behind your firewall, and whatever data you want to export to that, we export to the world and make it openly accessible. That's the idea. And we can make it totally openly accessible or controlled by some sort of community access. So it doesn't have to be global public, it can be local public of sorts. Federation models, goals for 22, the regional self-storage system, the caches in the Internet 2 backbone, and then NRP is fully interoperable with everything Manish talked about in the beginning and with regard to path, credits, and all that kind of jazz. And so NRP, in essence, will take transparently jobs from OSG. It will move jobs transparently into OSG. It will take data transparently from OSG, and it will move data into OSG because the two systems will be completely interchangeable while they are independently run and operated. They federate. In essence, we eat our own dog food. Finally, I want to add one thought on access. Manish talked about this, and I added this slide in literally after Manish's talk. I think it's important to be cognizant that there's at least 4 different kinds of access to compute, and in principle, also 4 different kinds of access to storage. The technical implementations are more complicated. So you have free as in access to the open science pool operated by Path. Any student, researcher working in any US-based faculty, researcher project can get an account, and by getting an account, you get a hunting license to operate in a fair share batch system for free. Then the next one is in kind. Most of my talk was in kind because I'm talking to you guys. You have collaborators nationally and internationally, and for you, the in kind is maybe the most important. In kind contributions, and then there's the credit that Manish talked about this morning that you get via your award, and then there's the allocation that you can receive part of a national allocation process, whether it's a DOE allocation process, an NSF allocation process, doesn't matter. And our job is an open infrastructure provides the plumbing to exercise any of the above. So the notion is that the benefit of an open infrastructure means that you can combine any access model that you have with any other access model, and therefore operate on this open infrastructure in ways that you combine your resources and get the most done. Thank you.